Hello and welcome everyone. This is Rasayan Sikshak and we are today starting our new lecture series for class 12th. This is a new chapter, solutions, through which we will go today. So first of all, what are solutions? You are already familiar with the term in previous classes also. Solution is nothing but a homogeneous mixture. We will be dealing with binary solutions in this chapter, and as you all know, the binary solution means two. It consists of two parts, solute and solvent. Solute is that part of the solution which is present in less amount, and solvent is that part which is present in more amount. There are many examples in our day-to-day life regarding solutions. For example, the fruit juice which we are taking, the tea which we are making, or different types of solutions which we use. For example, the sanitizer is very famous now at this time because of COVID-19. So these all are solutions. What happens? The amount of solute for different types of solution is different. What I said? The amount of solute for different types of solution is different. So how will you know, or what are the parameters to estimate the amount of solute which is present in the solution? So in chemistry, there are certain mathematical parameters by which we can measure the concentration of solution. In earlier classes, पहले की क्लासेस में आपने पढ़ा है ये बात कि कुछ सॉल्यूशन को हम क्या कहते हैं, कंसंट्रेटेड है, दिस इज कंसंट्रेटेड, एंड कुछ सॉल्यूशन को हम क्या कहते हैं, डाइल्यूट. ऑब्वियसली इफ यू आर मेकिंग अ सॉल्यूशन ऑफ एसिड, अगर एक एसिड का सॉल्यूशन बना रहे हो और एसिड का अमाउंट किसी सॉल्यूशन में ज्यादा होगा तो वो सॉल्यूशन क्या होगा, कंसंट्रेटेड होगा. So what are the different mathematical parameters by which we can measure the concentration of a solution? In this or in today's lecture, we will know about all those parameters or all those units by which we will be familiar about different types of solution and the ways by which we can measure their concentration. So let us start. Units of concentration. First of all, the first unit of concentration, or you may say, or it is a parameter to measure the concentration, is mass percentage. Sometimes you have seen that it is written on the reagent bottle that there is a 10% solution of anything, suppose that glucose. So if it is written 10% solution of glucose, it means that 10 gram of glucose is dissolved in 90 gram of water to give 100 gram of solution. Next, what is the way to calculate? So the formula for mass percentage becomes mass of solute by mass of solution into 100. Mass of solute by mass of solution into 100. This is mass percentage, and you have already studied about it in class 11th also and previously in class 9th also. Let us go to another parameter, that is molarity. Now what is molarity? First of all, let us define what is molarity. Molarity, it is the amount of solute dissolved per liter of solution. So what is the way to calculate molarity? See, we represent molarity by the capital letter M, and here the formula is W2 by into 1000 by M2 into W1. What is W2 here? The W2 is mass of solute. M2 is molecular mass of solute, and W1 is volume of solution. Remember students, you need not use this 1000 always. Only when the volume of solution is given in ml, then you have to use this 1000 to convert the ml to liters. But if it is already given in liters, then you need not use this 1000. So this is already studied in molarity, so we will not go so deep for this topic. Let us proceed to a new topic, that is called normality. That is called normality. Now what is normality? As in case of molarity, the formula was written as W2 into 1000 by M2 into W1. Everything is same except this M2. There in case of normality it was molecular mass, but here it is equivalent mass. This is a new topic for you. And what is equivalent mass and how we can calculate the equivalent mass for different types of substances. So here we are calculating normality and M2 is equivalent mass. Now we have to be familiar with the topic equivalent mass. I hope that you will note down all the formulas related to equivalent mass, because this is totally a new topic for you. For example, if I consider any first element. For element, if you need to calculate the equivalent mass, then equivalent mass becomes atomic mass by valency. Atomic mass by valency. So if you need to calculate the equivalent mass for any element, for example sodium or oxygen or phosphorus, then you need to put its atomic mass here and divide it by valency. Second thing, if you need to calculate the equivalent mass for an acid, for example the acid is H2SO4, then you need to divide the molar mass of acid by the basicity of acid. Please concentrate here. In case of H2SO4, when we calculate the molar mass, we see that it becomes 98 gram per mole. 98 gram per mole. And the basicity for acid, what is basicity? You all are knowing the number of ionizable hydrogen atoms present in any acid is called its basicity. In case of H2SO4, the basicity is 2. So the equivalent mass for H2SO4 will be 49. It will be 49. Why? Because we divide the molar mass by basicity to get the equivalent mass of any acid. Now, let us go for a base. So if it is base and you need to calculate its equivalent mass, then the equivalent mass becomes molar mass by acidity. Molar mass by acidity. So you have to divide the molar mass by acidity. Acidity, as you all know, the number of hydroxide ions present in any base is called its acidity, and if it is acid, the number of ionizable hydrogen ions present in any acid is called its basicity, and it is already made clear by an example also. Now let us take an example for the calculation of normality. For the calculation of normality, I suppose that 0.49 gram of H2SO4 is dissolved in 250 ml of solution. 250 ml of solution. What I said, you have to take equivalent mass. The equivalent mass was 49 for H2SO4, and the formula for normality is again W2 into 1000 by M2 into W1. So what happens? In place of W2, you have to place the amount of solute. So it is 0.49 into 1000 upon, what is M2? M2 is 49, and here W1 is 250 ml. That is the volume of solution. What happens when we divide it? It becomes 10 to the power minus 2, 0 cancelled, and 25. So it becomes 4 into 10 to the power minus 2, and the relevant units are placed. See students, what is the difference here in case of molarity calculation and normality calculation? In case of normality, we use equivalent mass instead of molecular mass. Instead of molecular mass, what we use? We use equivalent mass. And for calculation of equivalent mass for different types of substances, the formula is always different. Let us in the end give some more formulas for calculation of equivalent mass. For example, if you are said to calculate the equivalent mass for sodium carbonate, so if it is a salt, then the formula becomes molar mass of salt by total positive valency on sodium or metal atom. So remember, if you need to calculate the equivalent mass for a salt, you have to divide the molar mass of salt by total positive valency on the metal atom, or here it is sodium. So the total charge on the sodium here is 2. Let us calculate the molar mass. So molar mass is 2 into 23 for 2 atoms of sodium, plus for carbon it becomes 12, for oxygen it is 3 into 16. So 3 into 16 becomes 48. 48 plus 12 becomes 60, and 60 plus 46, it becomes 106 gram per mole. Again, for carbon it is 12, for oxygen it is 16. So 3 into 16 becomes 48. 48 plus 12 becomes 60, and 60 plus 46 for 2 atoms of sodium it becomes 106. So you need to divide 106 by 2 to get the equivalent mass of Na2CO3. So the equivalent mass is totally a new term for you, and the equivalent mass for different types of substances are calculated in different ways. And what is the unit for normality? Generally for molarity we use M or capital M. Actually its unit is gram per liter, and for normality it is represented by capital letter N. For example, we already have calculated the Normality for H2SO4, that came to be 4 into 10 to the power minus 2. So it becomes 0.04 N. So what do you mean by 0.04 N? It means that if there is 0.04 N solution of H2SO4, then it means that 0.49 gram of H2SO4 dissolved in 250 ml of solution. So students, this much for this class. Let us revise what all we have studied, and please, I request you all that please concentrate on what I am saying now. First of all, we came across the term solution. What is solution? Solution is a homogeneous mixture, and generally we will deal with binary solutions in this chapter, which consist of two parts, solute and solvent. Solute is that part which is present in less amount. Solvent is that part which is present in high amount. Now we say that some solutions are concentrated, some are dilute. Why we say that? Because the amount of solute in different types of solution varies. Listen students, you are already familiar with all this molarity, mole fraction. So we will not go so deep with those topics. For us, what is new? New is formality and normality. What is formality? Formality is used for ionic compounds, as already explained. And normality, in case of normality, we take equivalent mass in place of molecular mass. I must emphasize that you must know all the formulas for calculation of equivalent mass. So for calculation of equivalent mass, what you have to do, it is different for any substance. For acid it is different, as you have already seen. For base it is different, and for salt it is different. For any element it is different. So by this formula we can get the equivalent masses of different types of substances, which we can use to calculate its normality. Mole fraction and molarity, these things all are familiar with you. So in the next class we will go with some questions and calculations related to the concentration units. Thank you everyone. I hope you like it, and if you like it, please like, share and subscribe. Thank you.